Hello engineers and welcome back to Civil Nirman. Imagine you are about to design a massive factory or chemical plant. You have got the blueprint for every tank, beam and pipelines. Do you know what's the underfoot? See, topographic surveys are the detailed ground maps that tell us exactly that. They measure every hill, valley and feature on the site, so engineers can build safely and accurately. So in this video, we will cover why topo surveys are a must for the structural engineers and site planning in the industrial projects, how surveyors perform them and what kind of data you will get from them. So let's first understand why topographic surveys are essential. See, when it comes to industrial plants, nothing leaves our engineers guessing about the site. A good topo survey gives us that the lay of the land up front. And here is why they matter. First, safety and risk mitigation. See, topo data reveals hidden hazards on the site. For example, steep slopes or soft ground could threaten foundation or heavy machinery alignment. By showing ground instability or potential flood zones in advance, we can design around those issues and avoid accidents or structural failures. Second, drainage and water management. See, surveys map out the natural flow of water, creeks, swells and drains. With that particular information, engineers can plan stormwater systems correctly. This prevents flooding or erosion at an industrial plant. A crucial step when millions of gallons of water and chemical may be involved. Second, design efficiency and cost saving. See, accurate elevation data let us calculate exactly how much earth needs to be moved, that is cut and fill, right? That means no wasted digging or unexpected soil. We optimize the plant layout by knowing where to level ground or where to leave it as it is. See, precise survey also helps in estimate the material needs, so you are not ordering extra concrete or steel just in case. Next, optimum layout, land use. See, topography guides where we put buildings, tanks, roads and storage yards. For example, we can place heavy equipments or large tanks on naturally flat spots identified by the survey, and we avoid steep grades for vehicle routes. In short, surveys help us to maximize the usable land and make sure critical facilities sit on the best terrain available. Next, alignment and coordination. Say in a big plant, everything must align from conveyor tunnels to pipe racks. See, a topo survey provides reference points so that all the engineering teams like civil, mechanical, electrical, instrument, process, all the discipline work on the same map. See, these avoid clashes where, let's say, a plant foundation dips lower than the expected into a survey pit or in an existing pipeline. In summary, a topo survey turns uncertainty into clear ground truth. It keeps your project safe, on schedule and on budget by catching problems before construction starts. Now let's understand how these topographic surveys are performed. I'll guide you through a quick summary of these particular methods. So how do we actually collect this information? See, surveyor uses a mix of traditional instruments and high-tech tools. This goal is to capture the precise 3D model of the site. So let's first understand the traditional surveying method. The first, total station. See, a total station is like the modern theodolite with a laser. A surveyor set it up on the tripod and aims at a reflective prism. It measures the horizontal and vertical angles and the distance to the point. Each shot gives us a 3D coordinates, let's say X, Y and Z of a point on the ground or on a particular structure. See, by moving the instruments around and taking many shots, the crew builds up a cloud of points covering the sites. See, total stations are very accurate and they are great for detailed surveys around building, roads and equipment. Next is surveyors using GNSS receiver on a particular pole. GPS or GNSS surveying. For large or open sites, surveyor uses this GNSS, that is Global Navigation Satellite System, like GPS. A handheld or tripod mounted GNSS receiver picks up signals from the satellites. When combined with a nearby reference station or post-processing, we get centimeter accurate coordinates of each point. See, GNSS is fast for mapping broad areas, but it needs a clear sky view. See, it's ideal for quick gathering control points and scattered features across the plant. Next is leveling and total station. See, often survey teams also set up local benchmarks or control points using leveling or laser levels to tie all measurements into the project's coordinate system. See, these control points ensure everyone, architect, engineers, contractors, is working from the same reference points. Now let's understand what are modern survey technologies. See, newer tools can capture the landscape even faster and more comprehensively. Two key modern methods are drones with photogrammetry and LiDAR scanning. See, in the first one, that is drone photogrammetry, drone equipped with the high resolution cameras fly over the site along a pre-planned path. They take dozens of hundreds of overlapping photos of the ground from different angles. Special softwares like Pix4D or Drone Deploy then stitches this particular images together into a 3D model, and the process called photogrammetry finds common points in the multiple photos and calculate their positions, and the result is an orthomosaic map and a digital elevation model of the entire area. This method is very fast and cost effective for large sites, giving us the detailed coverage of the terrain and surface features. Next is drone with LiDAR scanners in flight, laser scanning. So basically it uses the lasers instead of photos. A drone vehicle or tripod mounted unit emits thousands of laser pulses per second towards the ground, and each pulse reflects off the terrain or the objects and return to the sensors. So ultimately in this particular method, by measuring the time of flight, the equipment computes an extremely dense set of XYZ points. LiDAR is an excellent in wooded or uneven areas because lasers beam can penetrate gaps in vegetation and measure the bare earth and structures beneath. In this particular, the output is an ultra detailed 3D point cloud of the site. In many projects, surveyor combines method, for example using GPS for control points, total station for critical edges, and drone for overall coverage. The end goal is always the same: produce a complete model of the site surface and features. Now you might wonder, using all these methods, what are the data which are collected in the topography survey? So what exactly do you get from all this surveying? See, a topo survey documents every relevant site features with spatial coordinates. In practice, the survey report or the map is included. Next is 3D point cloud representation of the site. Elevation points, a list of XYZ coordinates for ground points and key locations. See, this point data are often used to create a digital terrain model, especially every measured spot from the pavement corners to the soil surface is captured here. Next, they collect is contour lines. See, lines on a map connecting points of equal elevations. So contour translates the 3D points into an easy to visualize 2D map. So here, remember, close contour line means steep slopes, lines far apart means gentle slopes. Engineers use this contour to quickly see ridges, valleys, and overall gradient across the site. Man-made feature. See, the survey shows all existing structures installation on the site: buildings, storage tanks, pipes, curves, fencing, utility poles, overhead cranes, road edges, and so on. See, for each feature, critical dimension or edges are noted. For example, the footprint of a building or the line of a pipeline is drawn. This ensures that your design wouldn't conflict with what's already there. Then natural features. See, everything native to the site is also recorded. That means streams, ponds, vegetation lines like the tree edges or wooded areas, rock outcrops, and ditches. Even a small detail like the ditch depths or boulder locations can appear. All these matter to the structural engineers. For example, a tree line might mark a soil type change, or a stream defines where you can't place a foundation. Next, they collect property lines and benchmark. See, a topo map includes the legal boundaries of the property and any survey control points established. This ties the surveyors to the real world coordinates, which are latitude and longitude or local grids. Knowing that the property limits is crucial, so your plan stays within its site. With this particular data, engineers overlay their designs right onto the top of the site model. For example, by placing the building plan over the contour map, you can instantly see if a foundation slab ends up on a slope. If you have to run a pipeline, the manhole locations show up against the terrain, Essentially, topographical data will give you the reality check canvas for all the structural planning. So, in conclusion, topographic surveys are literally the groundwork for any industrial plant project. They turn the unknown ground into a known map. By accurately measuring elevations and features, Topo survey ensures that the structural engineers start with the real data, avoiding surprises, reducing rework, and saving money. So from the total station to the drones and LiDAR, surveying technology gives us the detailed terrain models that inform every decision, foundation depths, drainage design, equipment placement, and more. In the end, knowing the exact topography keeps your plant design on a solid footing, both figuratively and literally. Thanks for watching. Keep this particular tip in your mind for your next project. A successful plant always starts with a great topographic survey. I'll see you in the next video. Till then, always remember, don't just learn software, learn concepts. Thank you.